Let's do another magnetic force on moving charges problem. An electron with the speed of 235 meters per second moves through a magnetic field of 2.8 Tesla. The magnitude of the force on the electron is 5.7 times 10 to the minus 17 newtons. What angle does the electron's velocity vector make with B, the magnetic field? So going back to videos 172, 173, 174, we dealt with something called the right-hand rule, right? And in that case, your thumb represented the magnetic force, your index finger represented the direction of motion of the particle, and your middle finger represented the direction of the magnetic field. All three of these which were perpendicular to each other. Now, again, that's the case in which the velocity is perpendicular to the magnetic field, which is perpendicular to the magnetic force. They're all 90 degrees to each other. Now, in those cases, we use the force formula for FB QVB. And this is the formula. However, in reality, this formula is only true when V and B and FB, they're all 90 degrees to each other. If the angle between V and B is not 90 degrees, well, now you have to multiply by the sine of the angle. So in reality, this formula becomes FB equals QVB sine theta. Okay, so you plug in the magnitude of these two, you multiply by the sine of the angle in between V and B. And of course, because it's sine theta, the maximum force will be achieved when these two are at right angles to each other. Okay? So what are we looking for here? The angle for the electron's velocity vector to make with the magnetic field. When this is the magnetic force, so we're told FB equals 5.7 times 10 to the minus 17 newtons. We're told the magnetic field strength is 2.8 Tesla. We're told the speed is 235 meters per second. So really we just have to plug this into the formula and solve for sine theta. So rearranging this for sine theta, we're going to get sine theta equals FB over QVB. And really you can drop the vector symbols because we're only plugging in the magnitudes here. The direction for this, always get from the right-hand rule if it's necessary. Okay, so FB is 5.7 times 10 to the minus 17 newtons divided by Q. Now, again, Q, where's Q? We're not given. Because it's an electron, just like I explained in video 174 where we had a proton, both proton and electron possess the charge of an elementary charge. 1.602 times 10 to the minus 19 coulombs. Now we can plug in the speed, 235 meters per second. B is 2.8 Tesla. So plug those in your calculator. Now this is going to return some number, and it has to be between -1 and +1. Otherwise you won't be able to take the inverse sine of it. And when you do this, you actually do get a number between -1 and 1. So sine theta is equal to 0.540737. So therefore theta is going to be equal to the inverse sine of 0.540737. And this turns out to be approximately 33 degrees. So the angle of the electron's velocity vector with the magnetic field is about 33 degrees. And that is actually it for the problem. Now I know I've been saying that for all these problems. The past couple of problems were actually pretty straightforward. Hopefully they were okay. Again, if you have any questions, be sure to leave them in the comments section below. Smash that like button if you liked it as usual, and subscribe to my channel so you never miss a video from me. So guys, stay tuned next time for video 176, Magnetic Force on Moving Charges 5.